As promised, in this video, we're going to take a look at rewriting a function in Vertex form when there's a lead coefficient other than 1. Because this is not an equation, we can't just divide everything by the lead coefficient because that wouldn't keep it equal to what we started with. We can't balance that by dividing w of x by 2. So instead, step 1 is the same. We're going to group our x terms together. And then we factor out that lead coefficient from the first two terms. Just the first two terms. We're kind of doing a partial factoring. Kind of like when we factor by grouping and we just do the GCF for the first two terms and then the GCF for the last two terms. We don't have to factor the a out of our c, our constant. And then we complete the square with what's inside the parentheses. Remember, we have to have a lead coefficient of 1 before we complete the square, so that's why we factored out that 2. Now I put some asterisks on parts C and D for completing the square because these are a little bit different than what we do the other times we learned completing the square. So we still cut the b value in half, square it, and add it inside the parentheses. The next piece is what's a little bit different. And I had a hard time wording it. So here is what the step says. Multiply what you added by a, and then subtract that value outside the parentheses. First I'm going to write down my negative 22. So remember, inside the parentheses, this is all being multiplied by our 2. This is distributive property. We had the 2 times the x squared, which gave us the 2x squared we started with. This gave us the negative 8x. And we are multiplying that value by 2. So I'm not just adding 4, I'm adding 4 times 2. So I have to balance that by subtracting 4 times 2, or 8. So when I factor this, the GCF stays out front. What's inside the parentheses factors as a perfect square trinomial. And then outside the parentheses, we simplify to get a negative 30. So our vertex is 2, negative 30. Remember that lead coefficient, that 2 doesn't affect the vertex. That would be a vertical stretch by a scale factor of 2. That is not a shift, so that doesn't matter when we're looking for our vertex. All right, let's take a look at another example. Same thing, isolate those two terms with an x, and then factor out the lead coefficient just from your two x terms, not from your constant. Complete the square inside the parentheses, cut that b term in half, square it and add it inside. Outside the parentheses, we're going to add 3 times 1, and then we factor what's inside the parentheses, drop down the x, the plus 1, 1 plus 3 is 4, and then our vertex, using the asylum, we get negative 1 to positive 4 for our vertex. Again, if you're confused, I've got a couple more examples. Maybe seeing the process a couple more times will help. Otherwise, we'll get it taken care of in class. So we'll start by isolating those two x terms. And then we've got to get our lead coefficient to be 1, so we factor out a from our two x terms. Then we complete the square with what's inside the parentheses, so I start by dividing my b term by 2. Square it and add it inside. And then I have to distribute that a to that term I just added. So I'm not adding 9, I'm adding 9 times 4. So I'm going to subtract 9 times 4 on the outside. Factor, drop down the x minus 3 quantity squared. Simplifying on the outside, we have 51. So our vertex, remembering the asylum, is 3, negative 51. All right, one more. Once you feel comfortable with this, go ahead and jump to the u-try. I'm going to isolate my two terms with the x, factoring out my lead coefficient. completing the square inside the parentheses, cutting that b term in half, squaring the 4, adding it inside, and I didn't just add 16, I added 16 times negative 2. Now 16 times negative 2 gives us a negative 32. So I really added a negative 32. So now on the outside I'm going to add a positive 32 to balance it. Factoring my perfect square trinomial and simplifying on the outside, I get a vertex of negative 436 in your U-try problem.